Okay, in our third example, we're going to look to solve the equation secant squared of theta plus the tangent of theta equals 0 on this interval from 0 to 2 pi, inclusive of 0, exclusive of 2 pi. Okay. Now let's remember our Pythagorean identity. Right? Our main Pythagorean identity is sine squared of theta plus cosine squared of theta is equal to 1. Right? Now look at what happens, right? Look at what happens if I come and I divide everything by cosine squared of theta. If I divide every term by cosine squared of theta. Right? What that does is it provides me with another Pythagorean identity, which is that the tangent squared of theta plus 1 is going to be equal to the secant squared of theta. Okay. Now, I should recognize that I may use a Pythagorean identity because my equation involves a secant squared and a tangent, a linear term and a quadratic term, but they're not the same function. So I look first to say, can I make a quadratic substitution that'll help? Right? It won't always be the case that it'll work. Sometimes I may have other identities that I need to use. But here we can see that secant squared can be replaced by tangent squared plus 1, which will give me the function in terms of tangent, which is what I would prefer. So making that substitution, I have tangent squared of theta plus 1 plus the tangent of theta equals 0. All right, once again, all I did was replace that secant squared with tangent squared of theta plus 1 because of my Pythagorean identity. Okay. Rearranging this equation gives me the tangent squared of theta, right? And let's have the tangent squared of theta plus the tangent of theta plus 1 is equal to 0. Okay. Now, in looking at this, I already know that I'm going to need some additional resources, right? Because I know that in looking, if I were to make a substitution, right? If I were to say, hey, let u equal the tangent of theta, right? And I were to think about this as u squared plus u plus 1 equals 0, right? There's not a way to factor this with rational coefficients. Simply not going to happen, right? So instead I have to consider, well, how else could I solve? All right, well, I know that I can solve using u is equal to opposite b plus or minus the square root b squared minus 4ac all over 2a. All right, so I have here negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 1 all over 2. All right, so that tells me that u is going to be equal to, right? That tells me that u is going to be equal to negative 1 plus or minus the square root of negative 3 all over 2, which would be negative 1/2 plus or minus I root 3 over 2. All right, which, using my substitution, that would mean that the tangent of theta is going to be negative 1/2 plus or minus I root 3 over 2. Okay. Now, for this problem, let's go ahead and just leave it at that point. We'll say, hey, that tangent of theta needs to be equal to this particular value, right? In more advanced math courses, we'll be able to discuss, right, what this could represent. This negative 1/2 plus or minus I root 3 over 2. Okay, now in terms of my original function, I could come over here and say, well, what would that original function look like if I were to graph it, right? So if I were to graph the secant squared, well, here's a way that I could do it. So I'm going to have y1 be cosine of x, but I'm not going to graph y1. But y2, I'm going to state is going to be, right, well, y variable is going to be y1 squared, but that's going to give me cosine squared, and I don't want that, right? So instead, I'm going to say, I'm going to have the fraction 1 over y1 and square that, and that's going to give me secant squared, and then plus the tangent of x, and I need to find out when's that going to equal 0, and I'm doing it on the interval from 0 to 2 pi, so I can set my window 0 to 2 pi, pi over 2 as my scale, and I can go to graph this, and let's see what happens. So this may take a little bit of time to graph, but that's okay. But I'm trying to find if on this interval there are any places where my function intercepts the x-axis, right? Because I'm saying, hey, is there anywhere that I'm equal to 0? And what I notice is nowhere on the function am I equal to 0. Right, so what I have is, yes, my tangent of theta is going to be equal to this, and in fact, I know I'm going to have no real solutions. Right? There are going to be no real solutions. All my solutions are going to be imaginary. Right? And in more advanced classes, we could talk about that, but I do have my graph that shows me no real solutions, and I do have the value for the ratio tangent of theta that I could determine.